Probably a good time to kick off. So let me start by saying good morning and welcome to today's live webinar on the topic of EV charging infrastructure. This event is proudly brought to you by Middies Tech Energy and NHP. Just some quick housekeeping before we begin. Today's session will run for approximately 1 hour. There is a Q&A tab available in Microsoft Teams, so please feel free to ask any questions that you may have, and we'll aim to cover as many as possible during the Q&A following the presentation. Please note that this webinar is being recorded and you will all receive a link in the coming days to view the recording on the Middies Tech Energy website. I'd like to now introduce you to our guest speaker, Ross De Rango. Ross is a Melbourne-based robotics engineer working for NHP on emerging technologies. Previously at NHP, Ross has held technical marketing, sales and team leadership roles across industrial automation, machine safety and hazardous area portfolios. At present, Ross's main area of focus is electric vehicle infrastructure. As well as supplying equipment for EV charging, NHP is working with many parties on the development of technical solutions, standards and codes in this emerging area. Without further ado, I'll pass over to Ross to commence his presentation. I'll just stop sharing my screen.
Very good, thanks Jess. Can I just make sure you can see the screen okay there?
I can see that. Bear with me. That's live, Ross.
Excellent. All right, in that case, I'll get started. Thank you very much, Jess, and thanks to Middies for hosting the event. Thanks also to all the attendees for taking the time to attend. You can see from myself, I'm working at home in these COVID times, and there's lots of Victorians who are on the call in similar circumstance. Please forgive me if there's a bit of noise in the background. I live in Moonee Ponds. You can actually hear an aircraft going overhead just now, so we'll make the best of it we can. As Jess has introduced, the topic of today is electric vehicle infrastructure. This is an area that I'm particularly passionate about, and that's important for our industry, as we'll cover as we go through the presentation. The first piece that I wanted to address is that electric vehicles are definitely coming. Whenever a question of this nature arises, whenever this topic is discussed, one of the first things that often comes up is, will this actually happen? It is happening, it's happening globally at scale, and the reason that we're going to see more EVs in future is that they are cheaper to run than petrol cars. So right now, today, there is a price premium for the electric vehicle to buy because there's a battery in it that costs money. But in terms of operating cost, the electric vehicles are cheaper per kilometre driven by up to 85%. By way of example, I drive an Outlander plug-in hybrid, so that's a vehicle shown in the picture on the screen now. It's got a battery in it that gives me 50 k's of range and a petrol engine for when I'm going further. When I fill it up on petrol, I'll get maybe 7 litres to 100 k's, costing me $10 or $11 per 100. When I fill it with electricity, at retail residential rates, it costs me maybe $4 per 100 k's. At commercial electricity rates, it costs me more like $1 or $2 per 100 k's. And that really is the difference. That's the reason that people are going to be shifting to EVs in future. Obviously, with battery prices coming down, EVs are getting cheaper and cheaper to buy. So there's a tipping point coming fairly soon where EVs will be the logical economic choice for most people. There's a longer term view here as well. So the Australian Energy Market Operator, we're doing a fair bit of work with them around what the future uptake rate of EV looks like and what that's going to do to the grid and our buildings. The AEMO modelling is that about 50% of new vehicles sold in about 10 years' time will be plug-in hybrid or battery electric. So a vehicle that's looking for somewhere to plug in and charge. We hang on to our vehicles for a long time in Australia. So this isn't going to translate to half of the fleet on the road being electric in 10 years' time. It's half of new vehicles, meaning about 10% of the fleet. That 10% of the fleet represents about 1.5 million cars, all of which are going to be looking for somewhere to plug in on a regular basis. Looking a bit more globally, in 2018, Volkswagen announced that they'd committed 60 billion Australian dollars to the procurement of batteries. They've got factories that are underway to be producing nothing but EVs within a couple of years' time. So Tesla gets a lot of press in the EV space. Certainly they're the market leader, but every other major automotive brand is heading in this way as well. It's going to be a very exciting space over the next 5 to 10 years. Moving a bit into why this matters to the electrical industry. Why does this matter to NHP, ABB, Schneider? Why does it matter to MIDIs? Why does it matter to the electrical contracting fraternity? If we look at how much petrol we use in this country, so petrol, diesel, liquid fuels that goes in our light vehicles, we use about $50 billion a year in total, and about half of that, about $25 billion, goes into the light vehicle fleet. As these vehicles shift from using liquid fuels to using electricity for fuel, this energy that is the motive for transport is going to be delivered largely in our homes and in our workplaces. I will stress here that not every vehicle is going to go electric quick, right? You're going to see people driving V8 Commodores for a long time yet, because there are people in our community who really love those cars. And there are use cases where electric's not a great fit. But for the typical suburban light vehicle, electric will work great. And the energy delivered for them can only be delivered through equipment installed by electricians. This is a space where we're going to go from petrol stations all over our suburban spread, which a person uses once a week, once every 2 weeks, a couple of times a week, to plugging in at home on a regular basis. And the equipment to make that happen is going to be bread and butter for our industry. So that's kind of the high level context setting bit. I'm going to go into some of the nitty gritty now around EVs and how they work. Often we get this question around range anxiety. So how far will a vehicle go on a charge? There's a Tesla Model 3 pictured there. They were launched last year. Depending on what options you go with on that vehicle, you'll have a battery somewhere along the lines of 80 kilowatt hours with a range along the lines of 500 Ks. And if you run that flat, you are stuck. It's time to call a tow truck. There's no walking down to the petrol station to get a 5-litre jerry can and fill it up. The size of that battery, for context, 80 kilowatt hours is about the electrical usage of a typical Melbourne household for about a week. It is a lot of electrical energy stored in that vehicle in order to deliver that range of driving. By comparison, the Outlander plug-in hybrid that I mentioned earlier, that's a vehicle that still retains a petrol engine, but it also has an electric drivetrain and a battery that'll give you enough range for your day-to-day commuting. So the idea there is you top it up each day, you start each day with 50 kilometers of range. Once you finish your 50 kilometers, then it'll switch over to petrol. Or if you're using your vehicle to do a long family holiday, so I take my family on camping trips when we're allowed to, when we're COVID normal, we'll be going up to Halls Gap or Bright. And on those trips, we use a little bit of petrol because that's outside that 50K range. But for all the day-to-day commuting around the city, 50Ks will cover it. That's kind of the spread of how far they'll go. I'll talk more in a moment about what that means for recharging and where and when you recharge. So everyone on the call is no doubt familiar with driving a petrol or a diesel vehicle, where the mode of recharging is that you lob up to a petrol station on a periodic basis and fill the tank. Delivering energy into a vehicle at a petrol station is very, very fast. A minute or two to deliver 40 or 50 litres of fuel is a very fast rate of energy transfer. Battery technology, and certainly the grid infrastructure technology, is not really aligned with doing that much energy transfer into a car that fast. But in terms of what's convenient for the driver, it doesn't actually need to be. If we think about the typical EV driver, they're going to get home after their day at work, they're going to plug their car in when it's in their driveway or the garage, and there's 12 or 14 hours before that car needs to go anywhere. So there's a long period of time available to slow charge that car and refill however many kilometers you've used in driving that day. This is convenient to the driver, and recharging overnight is also what's good for the grid and also how to keep your electricity prices low. So it all lines up pretty nicely that that's how most people are going to recharge their car. That's that top line indicating that most charging is going to happen at home overnight when grid demand is light. And that charging mode will be AC. So 230 volt comes to the house, 230 volt goes to the car at a current of somewhere between 6 amps and 32 amps, and you charge over the night and start the next day with a full battery. We're also going to see that slow charging approach, that AC charging approach, at workplaces, shopping centres, hotels, car parks, anywhere where the vehicle is going to be there for a longish period of time, and there is value to the person who manages the infrastructure in offering that service. So in a shopping centre environment, for example, they'll put in AC charging and they'll make it free. The idea being that the amount of energy the driver consumes is very small in terms of the cost, but by offering that service, the driver will turn up to that shopping centre rather than the one down the road and spend their money in that premises. So this slow charging approach, this works really well if the driver is parking the vehicle for an extended period of time and can wait for it to recharge. If, however, I'm doing something like the Melbourne to Sydney drive, again, going back to COVID normal times when we're allowed to do such things, parking overnight in Albury, for example, to refill my 500 kilometre range might be part of my plan, or I might be trying to do that in a single day, in which case I need faster charging than AC. Charging the vehicle AC isn't going to meet my needs if what I'm looking for is to recharge the car in a 20 or 30 minute period of time. And that's what DC charging is really for. DC charging is saying we'll bypass the rectifier in the car that is taking the single phase AC and turning it into DC. We will instead bring DC direct to the vehicle at a level of 25, 50, 100, 350 kilowatts. This sort of charging is faster. The batteries in the vehicles are designed to take it. Obviously, it means there's more electrical infrastructure upstream. I've got a note there that it's 2% of the total energy or less. The reason for that is that even when you give DC charging away for free, you'll find that the convenience trumps free. So the drivers will often prefer to charge at home overnight, even when they have to pay for the electricity, rather than go to a DC charging station. The DC chargers are really aimed at the people who are doing those long drives and need to stop to recharge during the day, or for people who don't have access to charging at home in their car park or in their driveway. More about that in a minute. So that covers off range and where they'll recharge. The next thing we're going to cover is how fast they'll charge. So the simplest way to charge an EV is with a standard 10 amp GPO. Off one of those, you plug a cable in that comes with the car. You'll draw 8 amps continuously out of a 10 amp power point, and you'll get 8 to 12 Ks of range per hour that you're plugged in. Now, for some drivers, this will be enough. If I think about the way my wife drives her car, that vehicle is parked at our home in Moonee Ponds. It goes to the kids' school, it goes to the shops, it goes to her place of work in Sunshine, but it never does more than 40 or 50 kilometres of driving in a day, never does more than 5,000 kilometres of driving in a year. If that vehicle were electric, 8 to 12 Ks of recharging per hour plugged in would be enough. She wouldn't actually need any more. For my vehicle, on the other hand, for work, I will drive to regional Victoria and back, and then the next day I'll drive somewhere else in regional Victoria and back. If my car were pure electric, a simple power point wouldn't be quite enough to recharge me every day. So that's where we step up to the next level of charging. 7 kilowatts AC, 32 amps single phase. One of those will deliver 30 or 40 kilometres of recharging each hour. What that translates to is however far you've driven that EV with a 500 kilometre maximum range, if you plug it in when you get home, the next morning it'll be full, which means that's about as big an asset as you really need to look at in a domestic environment. Going bigger than that in a domestic home will increase the cost of the installation, but it won't really add much value to the driver. The next step up from that is where we go to DC. So as mentioned before, if AC charging is too slow for what the driver is trying to achieve, DC charging picks up where AC leaves off. So a 25 kilowatt DC charger delivering 100 to 150 kilometres of range in an hour, useful at something like a regional restaurant where someone might be leaving the capital city, driving 200 Ks to have lunch somewhere, and then looking to drive home. And in that period of time where they're stopped for lunch for an hour or an hour and a half, they might want to pick up enough range in order to get home. At that location, you don't need a super fast charger, you don't need 300 kilowatts, but 25 kilowatts DC is a lot more useful than 7 kilowatts AC. And then we've got 50 kilowatt DC chargers, and they go up from there. So to give you an idea, the biggest chargers currently on the market are 350 kilowatts. The market is heading in the direction of 475 kilowatts. So 1000 volts, 500 amps DC. Obviously, the car's got to be pretty specially designed in order to get rid of the heat that generates in the batteries. Much past 0.5 megawatt, there's not really a call for it in passenger vehicles. I've got a couple of examples shown here of things that are likely to happen in the environment that we work within, right? So I'll be really clear that we're not advocating these things are good ideas. What we're seeing here is the result of EVs coming into environments where there isn't a convenient place to park the car. So we've got lots of inner city suburbs around Melbourne, around Sydney in particular, where you've got terrace housing and the parking is on the street. That one on the top left is my car. I've blacked out the number plate because I don't need a nasty letter from the council. The one at the bottom right is in front of my sister-in-law's place. We're going to see increasingly a lot of this stuff around, and eventually the councils are going to start issuing fines and tickets for it because clearly it represents a hazard in the neighbourhood. The response to this is probably going to be DC charging in council-owned facilities and in shopping centres and communities. So instead of slinging an extension lead out the front window, what the driver will do is plug into a fast charger at their local shopping centre once a week while they're doing their shopping. Since the audience is mostly electrical contractors, I'm going to talk a little bit about AC single phase, AC 3-phase and DC. So you will see on the market 3-phase AC charging at 22 kilowatt. You'll see single phase charging and you'll see DC. Single phase charging is workable for every single vehicle. There's no car manufacturer building EVs who isn't making it possible to charge the vehicle single phase, because that's what's in everybody's homes. If you're trying to sell an electric car that can't charge single phase, you'll really struggle to sell that car. 3-phase AC charging is a middle ground between AC and DC. It'll let you bring energy to the vehicle a little bit quicker than single phase can, but it comes at the cost of the rectifier in the vehicle needing to be a bit bigger. This obviously adds cost to the vehicle. So a little while ago, Tesla were running 22 kilowatt 3-phase rectifiers in their car. They've now wound that back to 16 kilowatts or 11 kilowatts. And most car manufacturers are trending in the direction of a single phase rectifier in the car. To satisfy the fast charging requirements they have, they go to DC for that, because it puts the cost of the high power rectifier equipment outside the vehicle. It means that the consumer doesn't need to pay for it. That cost is borne somewhere else. I hope that makes sense to everybody. So the next piece I'm going to cover off is a quick piece about cable types. It'd be lovely if every car manufacturer in the world had standardized on one method of inlet into the vehicle. That'd make our lives on the electrical side much, much easier. But of course, the global car industry is global. Lots of people trying to pull it in different directions, so lots of different standards. On AC charging, there are 2 plug types that are relevant to Australia. The top one there is type 1, the bottom one is type 2. Type 1 historically has been used principally in Japan, so it was common on the older Nissan Leafs. Nissan has since moved to type 2, and you'll still see type 1 on the Mitsubishi vehicles. Type 2 is used by everybody else. So the charging equipment that we offer, and that is offered by many of the other manufacturers out there, you can buy a charger that has a lead that goes to type 1, a charger that has a lead that goes to type 2, and that's useful if you know what kind of vehicle is going to be connecting to it. So if you know that your customer's buying a Mitsubishi Outlander, you can supply him a charger with a type 1 cable. If you know that he's buying a BMW, you can supply him a charger with a type 2 cable. If the charger is going into a location where you don't know what vehicle will be using it, or various different vehicles will be using it, that's solved by selling a charger that has a socket outlet on it. So while all the global car makers weren't able to standardize on, shall we do type 1, shall we do type 2, we have been able to standardize on socket outlet AC chargers will all be type 2. So if you look in the back of my Mitsubishi, which has a type 1 inlet, what you'll find there is a cable that goes from type 2, designed to plug into a type 2 socket outlet EV charger, into the type 1 inlet on my vehicle. And anyone else who wants to use that charger, which is a type 2 socket outlet in my workplace, they would bring a cable that is either type 2 to type 1 or type 2 to type 2, depending on what their vehicle is. In this way, we can make it possible for anyone who wants to put in an EV charger that will work for everybody. They're able to do that just by using a type 2 socket charger. It's also handy because offering a charger that doesn't have a cable hanging from it means there's one less thing to be damaged in the field. Anyone who's gone to a petrol station and seen how air hoses are typically handled by members of the general public will understand what I'm getting at here. So that's AC charging. You can do it with a fixed lead that goes to one type of vehicle or a socket outlet that works for everybody. In DC charging, again, there's a couple of different inlet types, and there may be more as the power levels go up. But there are two in particular that are common in Australia. One's CHAdeMO, top left, and the other one's CCS2, bottom right. Again, Japanese vehicles tend towards CHAdeMO. CHAdeMO is also the standard that is best supportive of vehicle-to-grid charging at present, though CCS2 is catching up. In terms of how this matters to us, it's less of an issue for the electrical industry because everyone who is making DC charging equipment is putting both cables on the vehicle. So the next slide here, this is a Middy's branch up in the Northern Territory. This is Walnut. The DC charger that we've supplied for that installation, you can see there's two cables hanging from it. One of those is CCS2, the other one is CHAdeMO. So any vehicle driving up to this charger grabs the correct hose, just like grabbing diesel or unleaded at a petrol bowser, sticks it in their vehicle, and off they go. So from the electrician's point of view, it's easy. You just pick a piece of equipment that's got both hoses and you're away. There is an added benefit there that you can't accidentally put diesel in the unleaded tank with an EV charger. If you grab the wrong hose, it simply won't fit. I mentioned Tesla earlier, so just a quick note around Tesla versus other brands. It's pretty common when Tesla sell an EV for them to offer an EV charger with it. Tesla have also done some work in the market free issuing EV chargers to destinations, places like hotels, on the basis that the hotel install the EV charger and make it available for Tesla drivers. Tesla in the EV space have done some amazing work, but they are kind of a walled garden. They're almost like Apple in a way. They build charging equipment that's designed for use with their vehicles, not with everybody else. So if you're being asked to install EV charging equipment and it's only going to be used for a Tesla and there's a Tesla charger available for installation, go right ahead. If the intent is to make the EV charger available for all cars though, you probably want to look at a manufacturer that's one of the general electrical players. So get one that's come from us, from ABB, from Schneider. The team at Middy's will be more than happy to show you the options. All of the EV chargers from all of the major brands will work with Tesla and they will also work with everybody else. So the takeaway there is that buying a general one will still work for Tesla. You're not losing anything there, but by installing a general branded one, you're able to charge all EVs that are on the market and coming to the market. So a quick bit about standards. AS3000 is obviously the Bible for our industry. There's an appendix in there, which anyone who's interested enough to join this call should probably take a few minutes to read. Only runs about 6 or 7 pages. Appendix P, informative guidance around EV charging. By all means, read the whole thing. A couple of the specific takeaways that will be relevant to those installing this gear. Circuit protection should break phase and neutral. So this typically means allow 2 poles in a domestic load center or allow a long body that'll do the neutral as well. You need type A or type B RCD depending on the charging hardware. So what this is getting at is because the EV has a big rectifier in it, it is effectively a really large switch mode power supply. The concern that the regulators have got around that is that this can create DC leakage currents. In the presence of DC fault currents, we can end up with a type A RCD not working correctly. The DC fault current can swamp out the function of the RCD. A type B RCD detects this. So if the EV charging equipment can't handle DC fault current detection, you should be looking at a type B RCD upstream. If the EV charger can handle DC fault current detection, then you only need a type A RCD upstream. Anyone who's looked at various different RCD types will know that type B RCDs are far less commonly used and they are more expensive. So one of the gotchas in this industry is when you're installing EV chargers, look for one that can handle DC fault current because it'll make your install cheaper. I'll put my salesman's hat on very firmly here and say the NHP equipment can certainly support a type A in this context. It's just been a quick note pop up. It was a little late. Are you going to make the presentation available after? Yep, presentation will be available after the show. Last note on this slide, 32 amp single phase circuit for typical domestic install. So I mentioned 7 kilowatt AC, 32 amp, that'll typically mean 6 or 10 mil cable. Obviously it depends on installation. All the standard voltage drop calculations and whatnot apply. I'm going to talk a little bit now about load management. Not going to dive right into the weeds on this, but to address it as a challenge that's going to come up as EVs scale. This chart here is a load profile from an apartment complex in Melbourne. 82 apartments on a series of 3 really hot days. The middle day here was 40 degrees during the day and only dropped to 30 overnight. On this particular day, the grid had real trouble in Melbourne. What you can see there is a characteristic behaviour of evening times, 3 in the afternoon through till about 6 in the afternoon, everyone absolutely hammering their air conditioning. And that's the time frame where demand in the building hits a peak, right? We're looking at on the order of 200 kVA at peak. But if we look in the evenings, even on those really hot days, there's heaps of spare capacity here. The takeaway from this slide is that if we add the EV charging to the existing building load when everyone gets home from work, we're going to have problems. It's not going to take very many EVs at all before the main switchboard is really going to struggle on those hot days if the EV load turns up at the same time as the air conditioning load. But if we can shift the EV load into the evenings, there's enough capacity there staying within what that switchboard has historically delivered. So not even going up to the limits of what the switchboard can do, just staying within the limits of what it has done before. There's enough capacity there for more than 2 cars per apartment to recharge their daily energy use. What this tells us is that load management is going to matter. In an apartment complex, there's not going to be much appetite from the body corporate to triple the size of their network connection. What they'll be looking to do instead is put in some smarts that spreads that load out through the night. And again, without going into too much detail, NHP's got a range of different ways that we can help you in achieving this. So if you've got a customer who's looking to deploy EV charging and they're looking to ensure that they don't need to undertake high-level, expensive electrical upgrades, we've got ways to do that. This approach here is essentially taking the EV chargers, putting them on a comms network with some control equipment, either a BMS or a PLC, bringing in some energy readings from elsewhere in the building to figure out what's going on and how much spare capacity there is, and then sharing that available capacity across the EV chargers. Obviously, these systems can also report usage information and data to the body corporate. Somebody's going to need to address the billing piece in this as well, and we've got some answers there too. Again, in the scope of a half-hour general presentation, I'm not going to dive right into the detail here, but if anyone wants to talk about it in detail, happy to do that afterwards. So one of the other takeaways for this one, for any of you who are looking at doing commercial work, anyone who's deploying EV charging in an environment where the general public might be using the charger. This is commonly being done by places like pubs, restaurants, shopping centres, local government, those sorts of outfits. And one of the things that comes up is, where is the rest of the existing hardware? So look in the local neighbourhood at who else is doing it and what have they deployed. PlugShare is a free global map of where all the publicly available EV chargers are everywhere in the world. So there's an app on your phone. There's also a website that you can hit on your computer. If you take a look at it, you can zoom in and see where people have deployed EV chargers and made them available for general use. The orangey brown ones are the high-powered DC chargers. The green ones are AC chargers. So not surprisingly, AC chargers being cheaper to deploy, there's a lot more of them than the DC chargers. But if you look at the DC chargers, you can see coverage all the way around the eastern seaboard, around Perth, and in Tasmania of DC chargers already. This stuff has all been deployed in the last 5 years. It's still early stages of the market, but it's clear from that map that this isn't a trend that's going away. There's more and more of this sort of work being done all over the country. There's also some question here around EV readiness requirements. So as we shift towards electric vehicles, retrofitting of our buildings is going to be necessary. People who want an EV charger in their standard standalone domestic home, that's a fairly straightforward install, right? An extra RCBO in the load center, wiring to the garage or the driveway, put the EV charger on the wall, and you're away. In other kinds of building, it's going to be a bit more complicated. So in apartment buildings in particular, if there's nowhere convenient to run the circuit from, you might need to put in a new submain, you might need to put in a new distribution board, you might need more cable tray, all manner of stuff that's going to make it difficult to install EV chargers if the planning and the readiness piece isn't there. So as it stands today, there's no requirements in the National Construction Code to make buildings ready for EVs. But we at NHP and a bunch of other stakeholders in industry are working on that. What we're aiming at is having some EV readiness requirements written into the National Construction Code in 2022. So that'll take effect in 2023, 24. This is a couple of years away, but a heads up that industry is aware of it, and we're looking to do what we can in order that in future, our buildings are better prepared for this sort of deployment. As it stands today, anyone who's looking at sustainability ratings in their buildings, there's a Green Building Council of Australia Green Star scheme that allocates points for putting in 5% provision of EV charging in parking spaces in buildings. And there's also lots of requirements under consideration from local councils. So in Melbourne, for example, City of Yarra and City of Moreland are doing quite a bit of work around this. Canberra's doing some work around it. Parramatta in Sydney is doing some work around it. And we're involved in some of those discussions to help them write planning regs that make sense from an electrical standpoint. But there are more than 500 local governments in Australia, and industry obviously doesn't have the bandwidth to deal with them all one at a time individually. And that's really the reason that we're working at it from the National Construction Code standpoint. It'll work better for us as an industry if all the rules are consistent across the country and written in a way that every electrician can do it. That last point around what does future-proof look like? In our view, future-proof in a domestic building probably just looks like the cable run in to the point where the EV charger will be installed in future. So if you've got someone building a new dwelling, the question to ask up front would be, would you like us to install an EV charger? But if the answer to that is no, if they're not looking to spend that money today, installing the 6 or 10 mil cable today for use in future will make everyone's life a lot easier down the track. If we're talking about an apartment complex, future-proof looks like a distribution board in the car park with sufficient spare capacity to feed all the EV chargers in future, and some kind of plan around how the load management is going to be handled. And again, anyone who's looking to get into the detail on that discussion, very happy to help out. Last slide to show today, and then we'll go to questions as moderated by Jess. Where can you learn more? NHP has a bunch of brochures and selection guides on our website, so we sell lots of product. We've also got lots of technical white papers and information around this space that's useful for industry and for electricians to work through. So I've got a website there that'll be shared along with this slide deck at the end of the presentation. You can contact your friendly Middies Tech Energy team. So a shout out to Jared and Zoe in particular. They've been doing quite a bit of work around EV and I'll be very happy to help out. Or of course you can reach out to me. I'm posting my mobile phone number and my email address there. Feel free to reach out if you've got any questions. At that point, I'll close the formal part of the presentation and I'll throw back over to Jess to moderate any questions. I haven't seen that many pop up during the presentation, but please feel free to start punching them in and we'll work through as many as we can.
Thank you very much, Ross. We've had a couple come through and another one just now. Maybe we'll start with Darren's question of what do you know about a possible fuel tax that the government may charge?
Okay, so fuel taxation is a really interesting one. Currently, the federal government raises about $20 billion a year out of fuel excise, right? And a sizable chunk of this comes out of the driving public. An average driver doing $2,000 worth of fuel purchasing each year is paying about $800 in tax to the federal government to support things like roads, hospitals, the military, all the health, all of that kind of stuff. EVs obviously aren't subject to that tax currently. If I plug in my car at home, I'm not paying any fuel excise whatsoever. The fair way to resolve that probably looks like a registration charge being applied to EVs to cover off the fact that they aren't paying the fuel tax. It's going to be very, very difficult to separate out electricity used for the domestic home and electricity used for the vehicle. So taxing the electricity is probably not the way. It's more likely to look like a road user charge or a registration fee that is applied to vehicles which aren't consuming petrol. The model for this probably best seen is in New Zealand. So in NZ, you've got petrol, which is taxed, and you've got diesel, which is not taxed. But if you drive a diesel passenger vehicle, you pay an extra charge based on how much driving you do in order to fill the gap. Right now today, that's not really a big concern. There's not going to be a gaping budget black hole on account of EVs turning up anytime soon, but it is more of a fairness question. If you've got some drivers paying tax for road use and others not, then clearly that can't stand for too long before it needs correcting.
Excellent. Ross, we've had a question about how many Minis branches have a charger. Happy for me to talk to that one?
Absolutely, Jess, knock yourself out.
Thanks very much. So we have 5 chargers in our network, which consists of the DC charger at Darwin and AC chargers at other locations. And those locations are Lilydale, our Smart Centre in Mulgrave, Wodonga, and Hindmarsh, of course, with Darwin there. So 5, and we are extending those through our network. They can be found on PlugShare, the Middies website, and the back of the Middies mag, if you'd like to see those.
Very good. I'll just add in one more. You can see them at NHP Richmond and NHP Laverton as well. So if you're interested in seeing one, no problem at all. Happy to send you photos of installations. If you want to see one in the flesh, just reach out.
Excellent. Thank you. We had another question from Warwick. Are there pay-for-use charge stations available to install, e.g. credit card type?
Yeah, absolutely. So I didn't get into details in this presentation around payment methods. For most use cases, payment at the charging station is not going to be required. So if it's being installed in a domestic home, the usage is going to turn up on their electricity bill. If it's being installed in a workplace, workplaces typically aren't going to be trying to bill their employees for the use of electricity. They'll recover it another way. And if it's in a shopping centre, oftentimes it'll be installed for free. So the idea there is they're not worried about the 20 cents worth of electricity that you're consuming. What they're interested in is you spending a couple $100 in their shopping centre. That said, there are absolutely cases where pay for use via an app is an appropriate way to go. So within the EV charging range that we offer, there are models that will take a SIM card directly inserted into the EV charger. The EV charger then talks to a cloud-based service that manages the authentication to the driver via an app and then handles the billing on the back end. So in brief, the way that works is you as the driver log up to the EV charger, you get your phone out that's got the app, which is managed by the person who's managing the EV charger. You say who you are, you want to start charging. The cloud-based service starts the charger. When the charging session is done, you'll get a bill on your credit card, again, mediated via the app and the cloud service. And then the service provider will kick back the money minus any fees they're charging to the site operator. If you're interested in exploring those sorts of options, very happy to get into them. Yes, the hardware can be used with multiple providers of that type.
Thank you, Ross. Now we have a lot of questions coming through. Let's move on to one from Ross, which is, do all chargers work two ways in that a house can run off the car battery at night or during peak hours, or do we need a specific type of charger?
Yeah, okay. So this goes to the question of vehicle to home, vehicle to grid versus one-way charging. So every EV on the market is capable of being charged, right? That is delivering energy from the home into the vehicle. To get energy back out of the vehicle into the home or into the grid, you need to get from that battery into 50 hertz AC. The ability to do that isn't necessary for the car to be able to do its thing as a car. So most car makers aren't building that capability into their cars today. It's very much an emergent area. In terms of what goes on the wall, in order to do that, you need a bidirectional charger. So it's a piece of kit functionally pretty similar to a hybrid inverter that you'd use with a solar system, but these aren't available in the Australian market yet, right? There's trial programs being run. I think one kicked off in Canberra a couple of months ago, but this isn't, I guess, a product you can buy off the shelf today. When they become available, it will be a different piece of equipment. It'll be an expensive piece of equipment. And obviously it'll need to conform to different standards. So instead of, I guess, similar to your hybrid inverter that needs to be 4777 compliant, bidirectional chargers will be the same.
Thank you, Ross. A question on the PlugShare website. So what's the difference between the green and yellow symbols?
So the green symbols are AC charging, the orangey brown symbols are DC charging. very much encourage you to jump in and have a squiz at them, right? So you can dial right in there and you can see photos of the installations, and yeah, you'll pick it up pretty quick from having a look.
And that's just www.plugshare.com for those that are interested. Next question from Dave. How does a domestic solar, battery and car charge interaction work?
Very good question. So lots of people doing interesting work in that area. There are, I'll start with what most people are looking for in vehicle charging is to be able to charge their car overnight, because that's mostly when the vehicle is going to be present. So typically what you'll see is someone who's got solar and an EV, puts an EV charger on their wall, uses their solar during the day. If they happen to be at home when their EV is charging, terrific, they'll use solar. Otherwise, they'll draw it from the grid. If you're looking at a system that brings together the whole ecosystem of solar on the roof, battery in the house, battery in the car, and ties it all together, you're probably looking for a solution from a single vendor. So Tesla has done a little bit of work around that, but not many others are deep in that area at this stage. What I'm expecting to see, and this is yet to be proven, again, emerging area, we don't have a perfect crystal ball on it. I'm not really expecting to see people taking their energy from solar, putting it in a battery during the day, stationary in the garage, and then putting the energy from that battery into their car. It's going to be difficult for that economic model to stack up really well. The reason I mention that is that you can already get a retail contract from a retailer who will sell you energy overnight at the same price as the solar feed-in tariff. So it'll make more sense if you've got solar and an EV to let your excess solar during the day feed into the grid and get your 12 cents a kilowatt hour. And then in the middle of the night, when it's convenient to charge your EV, you're buying energy at 12 cents a kilowatt hour. So you're not net any better or worse off from doing it that way, but you don't need to bear the cost of the stationary battery in the home to achieve the goal. There's going to be all manner of people who will tackle that problem all sorts of different ways, though. So I'm certainly not speaking for everybody. It's yet to be seen.
We'll go through the 4 remaining questions that we have. We might have to cut it off there. But one of the questions is, will use of the car battery ever come into as use for the home similar to a battery or Tesla wall? Made comment that obviously only possible to charge daily at your workplace.
Sorry, I missed that. Can you have that question again, please?
Yeah. So it's will use of the car battery ever come into as used for the home similar to a battery or Tesla wall?
Okay. Yeah. So certainly it is technically possible. The question of whether it will become common or not is, I guess, at this stage a little unclear. There are certainly cases where a person who is a long way from the grid might see value in being able to take energy from their car to power their home during an outage as an alternative, for example, to having a diesel or a gas generator on site. The technical requirement to do that is similar to what I mentioned before. You'll need a vehicle to home or vehicle to grid charger to do that. And that piece of equipment will look very much like a hybrid inverter. It'll be connecting to the DC side of the car and then exporting 50 hertz AC. There is interesting work again being done by the car manufacturers around whether the cars themselves can export at 50 hertz or 60 hertz for the US market AC. If you're doing that for a standalone home application, possible. If you're trying to do it with the grid, then you need to do some synchronization between the grid and the car. So there's a lot of technical standards work to be done before that's feasible.
Thanks, Ross. So a comment that a shopping centre or business car park that is providing electricity to shoppers or clients, is this something that is charged at the charger point? And further to this, is this a marked up cost to allow this business to recoup this infrastructure cost for their customers?
Yeah, so if it's a piece of charging equipment at a location that's managed by a commercial operator, like a shopping centre or anything else, the price point that they apply to the electricity is whatever they want it to be. So they will instruct whoever the service provider is that is handling that service, what price to charge either per unit of energy, kilowatt hours, or per unit of time, number of cents per minute parked in the car parking space hooked up. and then they will be remitted those monies by the service operator. They can set that at whatever level they like, and then it's just a function of the market, whether the driver perceives that to be good value and decides to stop there. As an example, if you put in an AC charger at something like a shopping centre and you apply a high price signal to that, a person who is driving to that shopping centre from their home is unlikely to use it because it's cheaper for them to plug in at home. It's not actually a service they require. If, on the other hand, you're talking about a fast charger that is halfway between Melbourne and Mildura, and the person is stopping there in order to recharge their car, they will pay whatever they're told to pay. They're over a barrel, they don't have a choice. So the price there might be 40 cents a kilowatt hour, it might be $1 a kilowatt hour, and that is what the price will be as determined by the station operator. Regulation in this space is likely to follow whatever the behaviours of the operators in the space are. We're going to see some weird and wonderful pricing arrangements before things settle down.
And Ross, do you see a future for DC charging in a standalone domestic context if the manufacturers aren't going to support three-phase long term?
So that's interesting. We have seen a couple of customers put 25 kilowatt DC chargers in their domestic homes. As I mentioned earlier, I think this is overkill. It's not really something they need, but inevitably there's some customers who want that. And if it's something that they want and they're prepared to pay, then of course, as industry, as service providers, that's what we do. In terms of what the market actually requires, I think there's very limited need to charge vehicles any quicker than 7 kilowatts AC. Reason being that charging at that rate will give you a full recharge of a 500 kilometre range vehicle overnight. And if you can do that, if you imagine in your petrol driving context today, if you had a petrol fairy in your garage that was automatically topping off your tank every night and you started every morning with a full tank, how much more than that would you actually need? How much more than that would you be prepared to pay for? So I think on that basis, the first piece is the drivers don't really need it, so they're unlikely to want to pay for it. The other piece is that the networks are unlikely to want this outcome either. So we've already seen regulation in Queensland where Energex say if you're putting a charger in your domestic home and it's on the standard electricity wiring, not the controlled load tariff, you're limited to 20 amp single phase. If you put it on the controlled load tariff, you can go to 32 amp single phase. And they've done that because they're trying to forestall a peak demand problem on the network. So I'm certainly not saying people can't put DC charging or three-phase charging in their homes. They can, but I think it's going to be uncommon because it's expensive and it's not necessary.
We've got some questions in reserve. So what we might do, we'll go through these last two, and then we'll send any questions that we don't get to Ross to come up with a response, and we'll send those out as well, guys. So we've got a comment from Ben Talbot of New Energy. So he said that Tesla or Musk said on Battery Day that he doesn't think battery to grid was a big deal. Old Teslas could do it, but not anymore. Do you have anything to say on that, Ross?
What I would say is at a technical level, agree, not a big deal. It is a doable thing. There's standards and work in order to make it happen cleanly, but it is certainly possible. And there have been trials run around the world demonstrating that it's possible. The question really will be whether it stacks up economically as the way to solve this challenge.
Thank you. And a question from Charles. So with NHP chargers, can you set the time to say 12 AM to use cheaper power?
Okay, so that's a good one. The way that drivers set that is typically actually in the vehicle. So if I'm a driver and I'm parking at my domestic home and I'm on a tariff that is cheap from say midnight to 4 AM. So by way of example, PowerShop, for instance, has an EV charging tariff which is about 12 cents a kilowatt hour from midnight till 4 AM. What I would do is in my car, in the same way that I set my radio stations, I'll set my preferred charging time. When I get home, I plug into the charger or the power point, whatever it is I'm plugging into. The clock in the car keeps track of what time it is and will automatically let charging start at the time that I've set. So the timing is not set in the charger, in that example, the timing's set in the car. If what you're doing is using lots of chargers at a site like an apartment complex, then the way you handle that is a control system over the top that is telling the chargers what to do in an organized and orchestrated fashion. So the answer is yes, the charger can be told what time to start and stop charging, but that signal comes over a communications network. It's not done at the charger, and it is used in cases where you've got lots of chargers that you're managing. For the individual driver and an individual charger, the most convenient place for them to do that is actually the touchscreen in the car.
Perhaps we do have time for a couple of quick ones, if that's okay, Ross.
Yep.
So, can you see the government give further incentives or subsidies for EVs?
So I think the subsidies that have been rolled out to this point by government, maybe if I separate this out into state, federal, local, at a federal government level, there's been ARENA grant money for the rollout of high-power DC charging stations. And the reason for that is that deploying one of those is commercially difficult. You can't make the money back today off the energy you're going to sell to the person who stops at one of those stations a couple of times a year. So the federal government has provided a bunch of seed money around deploying those DC chargers so that city dwellers like me, if we're going to buy an EV, we can see that there is a network of fast chargers out there that we can use. Both federal and state governments have done a bit of that. In terms of subsidies for the vehicles, federal government is not particularly inclined to do anything around that, it seems. Various state governments have done things around stamp duty and around licensing and registration costs. So I think in Victoria, there's about $100 rebate on your registration. My personal experience is that it was more effort than it was worth to try and claim that. In the ACT, there's a stamp duty exemption, which is worth a bit more, a couple of $1,000s maybe. The countries that have seen the biggest EV uptake have subsidised EVs a lot more than that though. So if I look at Norway, for example, they're already at a point where more than half of the new vehicles sold are electric. They have exemptions that amount to a total of 30 to 40% of the value of the vehicle. So as a simple one, they run something similar to GST in Norway. They call it VAT, value added tax. That's priced at 25%. You are exempt from value added tax for an EV, but you pay it for a petrol car. So that's the scale of subsidy that has really tipped the scales in those other countries. In Australia, we're unlikely to see incentive at that level anytime soon, which means we will see EVs, but it will take a bit longer here. Because while they will commercially stack up by themselves, and for plug-in hybrid vehicles, they already stack up commercially by themselves, it's going to take a little longer in the absence of heavy incentive.
Perfect. And the lucky last, what kind of price are they looking at for the types of domestic chargers?
Yeah, sure. So that's probably best answered through your local team at Middies, to quote you on the Delta gear. You will see chargers in the market in domestic ranging from about $1,000 to about $2,000, depending on features, quality, warranty, all that kind of thing. A typical price for a standard domestic install on an EV charger, like hardware plus installation, would be around $2,000. Obviously, that will vary depending on the nature of the install, right? There's going to be places where you need to tear up concrete in order to lay the cable. That's going to cost more. But yeah, if it's a particular price inquiry, happy to take that up offline. Absolutely.
And in the recording that we'll send out, we'll send some details for Ross and our Middies network as well to find your local branch. So obviously, thank you so much, Ross, for presenting today and going through the list of questions that we have. I'd just like to quickly close off on some information about Middies Tech Energy. So Middies Tech Energy have a dedicated training coordinator, Al Ruley. We offer a suite of in-person and virtual training courses for all electrical contractors and trade professionals across multiple areas, including Introduction to Electric Vehicle Charging Equipment, which is presented by Ross De Rango. Our training supply partners are brands that you all know and trust, and classroom training takes place in our state-of-the-art training facility at the Middies Tech Energy Smart Centre in Mulgrave. So without anything further from myself, is there anything you'd like to say to close off, Ross?
No, just wanted to wish everyone the best for the day. Those of us in Victoria, how good is kids going back to school for the parents out there? I wish you all the best. Hope you have a good and productive day going forward. And yeah, any inquiries, please feel free to reach out.
Thank you very much, everyone. Have a great afternoon. Cheers.